Determine the reactions at contact points for spheres A, B, and C as shown in figure. It is given that WA equal to WB equal to 4 kN, WC equal to 6 kN, DA equal to DB equal to 500 mm, DC equal to 800 mm. This sphere is having 6 kN. Its diameter is 800 mm. These two spheres have 500 mm diameter and have 4 kN self-weight. We have to find out reactions at contact points P, Q, P, O, M and N and this point and this contact point, this contact point and this contact point. These are the self-weights and these are the contact points. These are the reactions on contact actions on contact points and these are the reactions. These are the reactions from the contact points. Action and reaction at contact point, they are opposite in direction. Now, to calculate reactions at contact points, now consider only self-weights and reactions. Now, on geometry part, first let us calculate this angle theta. This angle theta is got by the center to center distance is 600 meters, 600 mm, and this center to center distance is 250 plus 400. This will be equal to 650. This distance will be equal to 300 mm. 600 by 2, that will be 300 mm. Theta equal to cos inverse of 300 by 650 mm. So theta will come to 62.51 degrees. Now this angle and this angle will be equal. Now these are the reactions. Now consider self-weight and reactions. First consider this sphere C. This angle will be 90 degrees and this remaining angle will be 27.94 degrees. This total angle will be 90 and this angle we get by 90 minus 62.51. So we get this angle as 27.49 degrees. Now this angle is 90 and this angle, so this angle will be, total angle will be 152.51 degrees and this angle will be 54.98 degrees because this angle and this angle, they will be equal because both spheres, this sphere and this sphere and this sphere, they are symmetric about this 6 kilonewton force and this angle will be 152.51 degrees. Now applying Lami's theorem, 6 kilonewton by sine of the angle between other two forces, sine of 54.98 degrees and this angle divided by sine of angle between other two forces is sine of 152.51 degrees and this angle, this force divided by sine of the angle between other two forces, sine of 152.51 degrees. So this theorem again, calculating for RK we get RK equal to RL equal to Because this and this are same, we get RK and RL both equal to 3.382 kilonewtons. We got reaction at K and reaction at L 3.382 kilonewtons. Now we got this RK. Now here there are four forces, so we cannot apply Lami's theorem. Now applying equilibrium conditions, what we have here is this angle is 75 degrees. We need this angle. We need this angle. We need this angle. This angle is 75 degrees. This angle is 90 degrees. This angle is 90 degrees. And this angle is 15 degrees. And this angle is 15 degrees. And this angle will be 75 degrees. This is RP and this is RO. So this 75 degree horizontal will become this 75 degree vertical. So RP will be making 75 degrees to the vertical. Now consider joint A, sphere, this sphere, and resolving this force is horizontally and vertically and equating to 0. That is applying equilibrium conditions. Resolving this force horizontally, it will be RP sin 75 degrees, and resolving this force vertically, it will be RP sin 75 degrees. This is RP sin 75 degrees. It is directing towards positive x-axis, so RP sin 75 positive, and resolving this force vertically, it will be RP cos 75 degrees. It is directing towards positive y-axis, so it is RP cos 75 degrees. Now resolving this force horizontally, it is RK cos 62.51 degrees. It is directing towards negative x-axis, so RK minus RK cos 62.51 degrees. We know RK value, so RK minus RK cos 62.51 degrees, directing towards negative x-axis, so equating to 0. We substituting for RK value, we get RP value, and now resolving this RK vertically, it will be RK sin 62.51 degrees. It is directing towards negative y-axis, so minus RK sin 62.51 degrees. So, and one more force, this force RO directing towards positive y-axis, so plus RO, and this one more force minus 4 directing towards negative y-axis, so minus 4. We know RK value, substituting RK value, we get, so, and substituting for RP value, we get RO. What we have done here, we substituted RP value, and here RK, we know it is RK value, and for we are calculating for RO, so we get RO as 6.582 kilonewtons. So we got RP, RO. Now consider this sphere. We know this angle. We want this angle. We want this angle. This angle also we know. This angle is 65 degrees. This angle is perpendicular. This angle is perpendicular. And this angle is 25 degrees. And this angle is 25 degrees. And this angle will be 65 degrees. So this angle is 65 degrees. So now here there are four forces. We cannot apply Lami's theorem. Now applying equilibrium conditions, summation fx equal to 0 and summation fy equal to 0. Resolving this force horizontally, this is RL cos 62.51 degrees, and this is directing towards positive x-axis. So RL cos 62.51 directing towards positive x-axis, so plus, and this was RL sin 62.51, it is directing towards negative y-axis, so minus RL 62.51 directing towards negative y-axis, so minus, and this force RM resolving horizontally, it will be RM sin 65 degrees, it is directing towards negative x-axis, so minus RM sin 65 degrees, and this force resolving vertically, it will be RM cos 65 degrees, it is directed towards positive y-axis, so plus RM cos 65 degrees plus RM cos 65 degrees. And one more force here, calculating for RM, we know RL value, so RM we get as 1.722 kilonewtons, and here one more force Rn, it is directed towards positive axis, so plus Rn, and this force minus 4, it is directing towards negative y-axis, so minus 4 equal to 0. So substituting for RL and Rm and calculating for this Rn, we get Rn equal to 6.272 kilonewtons. What we got is reactions at contact points Rp, Rk, and RL and RO. So these are the reactions at contact points we got.